So let's clean up our workspace here. Now, in some videos, they wipe it off before the student gets there. I prefer to kind of mix it up. Sometimes you'll come back to a clean whiteboard. Sometimes you'll come back to what we were working on. It just kind of changes it up just like I do when I'm teaching a class face-to-face. So, along that lines, let's get back to it. Distributive property we talked about. Now let's look at factoring. Factoring is the distributive property in reverse. In factoring, what we do is we take out common numbers or variables in the opposite way. So we're going to end up with a parentheses and something on the outside. Whereas with the distributive property, we had something on the outside and parentheses. So in this instance, what is the largest value that these have in common? Well, we can divide a 4 into this. We can divide a 4 into that. So we're going to put a 4 here. And then we create our parentheses. But we've essentially done the opposite. Remember, in the distributive property, we're multiplying in. To get out, then we have to do the opposite, which is division. So 4 divided by 4 will give us 1, so we're just going to be left with x. Like, we could write it as 1x, but we tend not to. Minus 24 divided by 4 will give us a 6. Works the same with variables. If I had x, let's see, we have x squared plus 3x, making that kind of simple. We can factor out an x. Again, x squared divided by x will give us an x. 3x divided by x, the x's will cancel, leaving us a 1, but we don't need that, and that'll give us a 3. We have that. Now let's look at something a little bit more complicated, something maybe that has more values. Let's say I had a, let's go with 6p to the 4th minus 3p squared plus, let's see, 12p minus 18. All right? Well, out of 4 terms, doesn't matter. So I'm going to draw it underneath just because of space requirements. We say, what is the largest value? Let's look at the whole numbers first. What is the largest value we can take out? Well, we can take out a 6. No, we can take out a 3. So we do 3, and we are going to be left with p to the 4th. No, well, I won't be left with 3 to the 4th. Let's correct that. It'll be 2p to the 4th. Let's squeeze that 2 in instead of erasing it. Minus p squared plus 4p minus 6. Now you might be tempted, hey, we have these p's, we can get rid of these. Well, there's not a p in all of them. So we can't take a p on the outside. But let's say that we had something like similar. We'll just rewrite it. Instead of using a p, let's come down here. Give us more room. Instead of having a p, let's say we had 4. Yeah, let's stick with p. 4p to the 4 minus 8p to the 2nd plus 2, let's make that a minus, plus 2p. We could factor out, the largest we can factor out here is a 2. The largest p we can factor out is p to the 1, right? Because we can only take whatever the smallest one is, we can only take that out of everyone. So we end up with 2p, and what are we going to be left with? A negative 4 divided by a positive 2 will give us a negative 2. We have 2p to the 3rd. We divide that. That's going to stay the same. That's going to be 4p. And that's just going to be plus 1. 2 divided by 2 is 1. P divided by p is equal to 1. So in factoring, we simply take the largest value, whether it's a variable or a number or both. We take the largest value out of every term. And in order to factor, it has to be in every term.